Yeah, good
Hey,
morning, sir.
morning. Hey guys, just I'm confirming, right? How many things I have covered, right? I'm not pretty sure about this thing, right? I think so. I have done with the EIGRP, the basic of EIGRP. Let me know if I'm wrong. And we have done with the EIGRP packet types. We have done with the EIGRP stuff. We have done with the EIGRP summarizations, and we have done with the EIGRP name mode, and we have done with the EIGRP what we call the route state, the topology table information, this thing, right? Neighbor table, this thing, like how to check the neighbor table, what is the successor route, right? This thing, successor route, physio successor, right? And feasibility condition, we have seen that, if I'm not wrong, right? And also, I think so. 1 minute. Am I done with your route filtering? Yeah, route filtering, right?
Yeah.
What is happening? Okay, not EHRP route filtering, and path manipulation. Oh, perfect. So these topics are left only. Good. Very good example I have. Sexy. Now, how look? There's two cars I have in my home, right? So not my home. There's two cars in my there's two cars in the home right now. And take example. This car is not working well, so not working. And this is the owner of this building, right? Or because this is the owner of this beautiful house, and this owner is only driving this car. If you go to the market, having a date or any clubbing, anything, anywhere, right? If this guy is only going to use this car, the red one, not the this one. Now, so tell me, is there any benefits to have this car, or is there any benefits to put this car in my room? Sorry, in my house. Any benefit? No, there is no benefit. If I'm going to talk about, there's no benefit to to have this car in my house, because this car is not working. I have not been used this car last 3 years, right? So there is no use case of this car. This is is a what we call over this guy is a like unused car we have, unused information, we can say that. I'm not going to use this car. But if I'm going to have this car, if I'm going to have this car in my house, what happened? Two things we always have to do. One, we need to clean this car, right? At every month basis, right? Or maybe the weekdays or weekend. And second thing is what? I need to give some space. So in both the things, what happened? We are just going to pay the money. We are just going to pay the money. If you're going to maintain this information, right? If you're going to maintain this car, right, in your home, so what happened? First of all, you have to clean this car at every weekdays or the month basis or weekend basis, right? Any that's up to you. And after that, you have to give the space to this car, right? Same thing is happening with the networking, guys. In networking, what happened? Sometimes some information is important and some information is not important. In networking, also sometimes some information is important and some information is not important. Take example. Right now there's a, okay, let me open my GMs. Can you see the stop lossy right now? Okay, let me 1 minute. Let me increase it to the size. Mm, Session, save it, and then command. Show me the. I'll take a screenshot. All good. Come to the window. Now, try to understand what happened. R3 has some information, right? R3 has this three information in the R3 routing table. What R3 will do? R3 will share this information to whom? R2, right? And R2 will share this information to whom? R1. Try to understand ISP is what? ISP, R3 is behave like an ISP. Once I'm going to enable the EIGRP, once I'm going to enable the EIGRP on the router number 2, on the router number 1, at the same time on the router number 3, what ISP is doing by default, ISP will share all the routing information they have, right? All the routing information, whatever the route they have. If the router, if this guy has a 10,000 route, then it will share the 10,000 route to the R2 and 10,000 route to the R1 as well as, right? I'm just taking a small scenario right now. I have just three information right now in my routing table of R3. And once I'm going to form the EIGRP membership, what R3 will do, R3 will send this information to the R2 and R2 will share this information to the R1. Now, listen to me. Whatever the user are sitting over there, right? Whatever the user are sitting over there behind the R1. So take example, this some user are sitting over there, right? All this user, right? All this user is only interested to send the traffic. All this user is only interested to send the traffic to the to this guy and this guy, only to this guy. Whatever the user are sitting behind the R1, right? In my LAN network, whatever the user are sitting in the LAN network, they are only interested to send the traffic to this particular network. So in that case, what I can call this person, hey, these are my interested route, or we can say these are my used route, and we can say that this guy is what? This is the unused route. This is called as a unused route because my user is not interested to send the traffic to this particular network. And what I told you that if you remember, like in the summarization part, one route consumed almost 200 to 300 bytes of memory and some CPU as well as Remember the summarization part. So IP root summary command. Check it while using this one. So IP root summary. One route consuming the almost 200 to 300 bytes of memory and some CPU as well as, right? So tell me, this is unused route. Do I need to maintain this information in my R1 routing table? The problem is that this is my company, this is my own organization, right? This is my own organization. And what ISP is doing, ISP is sending the all routing information to the my organization, right? This is the ISP. ISP dot is sending all information to the customer. And customer need to maintain all this information. And this is what? This is an unused route for me. I don't want this information because whatever the user are sitting behind the R1 and R2, they are only interested to send the traffic to this guy and this guy. So what we have to do over there, guys, we just need to remove unwanted information from routing table. We just need to remove unwanted information from routing table. And that removing is known as a route filtering. I'm going to filter the route. Hope you remember, right? In the CCNA, you did your packet filtering. And here I'm doing the route filtering. Both are different terms. In a packet filtering, what happened? You're filtering the some packets, some services. Okay, this user cannot go to the cannot access the HTTP, the HTTP server. This user cannot access the telnet. You can deny some services and you can allow some services, right? Based on the requirement. But in the packet filtering, what happened? You are filtering some packets, but still router maintain route in the routing table. But in the route filtering, what happened? You are completely removing route from the routing table. You're applying the packet filtering, right? You're applying the packet filtering. How? You just need to create the ACL. And why do we need to create the ACL? To match the route, right? Like if you go to the shopping mall and how do you select the clothes over there? This is the shopping mall and this is the user over there. And how this user will select the clothes? They come to the shopping mall, they pick the cloth, they pick the cloth, pick the cloth, pick the cloth, pick the cloth, and pick the cloth. Because this is what? This is living things, right? They know which one looks good on me, right? This person is living things. They know how do I look good, right? But whatever the router, this router is saying that, hey, I'm a totally non-living things. I don't know which one is good and which one is bad. Router is saying that, hey, I don't know which one is good and which one is you tell me. This is the network engineer, and this network engineer will tell, hey, I'm giving the command to you. I'm giving the command to you. Which one is good and which one is bad? And how does router make a selection of the route? Based on the ACL. Based on the ACL, we are going to make a selection of the route. Like this guy's the living things. They can choose, okay, this one is good, this one is good, this one is good. But what about the router? How about the router? How the router is going to decide, okay, this look good and this look bad based on the ACL. ACL is what? It's a selection of the route, or we can say choose the route. Call the interested route. Call the interested route, interested traffic. All good. So what we are doing, we just need to find which one is the interested route I have. In a packet filtering, what happened? I just need to create the one ACL. For example, I say the access list 1 deny what like this, and I need to go into apply and the access group 100, sorry, 1 in 1, like that you are doing in the the packet will depend on the like requirement you have. You can use the standard ACL or you can use the extended ACL, you can use the name node ACL, up to you, whatever the requirement you have. But in the route filtering, what happened? I'm just going to match the route. Okay, which route I'm interested? Hey, I don't want this information. Which information? This information. But I want accept everything. I match the route. So what is the use of ACL? Hey, I don't want this person, right? This is the unused route for me. I don't want this guy. I only want 2.0 and 3.0. So I'm going to call in the permit any, right? So ACL is what? It's a matching the route, make a selection of the route, choosing the route, call the interested traffic, whatever things you can give it the name. Up to you guys, right? This is just a matching the route. Until or unless you are not going to apply the ACL on the particular interface, this is used to match the route. Whenever in the networking, you have to make a selection of the route. Okay, I have to do something with this particular route. I have to do something with this particular route. I have to do something with this particular route. Always you are going to make a selection. And how do I make a selection? Always you need to create the ACL. Whenever the selection comes in the picture, need to create the ACL. All good? And once we have done with the ACL, what happened? I make a selection of this guy, and now I need to apply into the distribute list that is used to perform the route filtering. I call this guy ACL number 1, and I'm saying inbound direction because this route is coming to me, right? This route is coming to me. What happened? I'm going to put this guy over there. This guy name is what? Route filtering. And what this guy will do? It matched the route according to the ACL because the ACL is again used to choose the route. Which route I'm going to choose? Only the permit any except the this guy, right? So they have a this one, they have a this one, and they have a this one. What this guy saying? Hey, according to my policy, I'm not going to accept 1.0. I'm going to only going to allow 2.0 and 3.0 information in my company network. So in that case, what happened? In that case, now this route will be removed from your routing table. No need to maintain this information. And that's how we are completely removing the unwanted information from your routing table, and that is called as a route filtering. For example, if I'm going to apply the same distributed list on the router number 3, what happened? I need to use, instead of the in, I have to go through the out direction. Direction important, right? Because if R3 is sending, it should be out. I'm receiving, it should be in. Again, for example, the condition is something like this: R2 need to maintain all information, but not R1. In that case, what will you do? You need to create this ACL. I'm talking about this command right now, this syntax. You need to create this ACL, right? And you need to apply this ACL into the outbound direction. on the router number 2. So R2 will maintain all this information. Now I'm going to apply the ACL on this particular interface, on this guy, on the outbound direction. So R2 will maintain all this information, but R2 can only share this two information to the R1. So this is like, it's totally up to you how you are like, managing your network. Depend on your network, right? Depend on your situation, you can change the thing. All good. Again, if you want to call the, for example, like if you have a look over there, if you this is the router over there, right? This router has a multiple interface 0/0. This is the 0/1, this is 0/2, and this is 0/3, and this is the 0/4. And as we know that every interface has a separate broadcast domain, they have a different connectivity. For example, I'm receiving the route from this interface 0/0, and I want to share this information from this interface and this interface, not to the this interface, not to the this interface, not to the this interface. Then what happened? I need to create this ACL, right? And I need to apply the distribute list on a particular interface, right? One out direction, I need to match the 0/1, 0/2, and 0/3. Hey, I want to deny this particular route from this two interface, three interfaces, right? 0/1, 2, 3, but it will be allowed from the 0/4 and 5. In that condition, you need to call the interface as mask. Again, what I told you that it's totally depend on to your scenario. But if I'm not going to apply any interfaces, for example, I just put the distribute list one out, what happened? It enable, right, on a all EIGRP enable interface. So what mic is on? It enable all EIGRP enable interface. That actually I don't know what condition is what. I want to filter that out from this three particular interface. So if you want to filter that out from this three particular interface, then you need to call the interface number. Someone mic is on. All perfect. So guys, I'm not telling you that you have learned in your CCNA that ACL is used to do the route filtering. I'm not telling you did you learned wrong. You are correct, learned correctly, right? But the thing is that actually the use of ACL is used to match the route. We can call the interested traffic, and we can see that what I call choosing the route, which route I'm interested. So if you have a look this topology right now, R1, R2, not R3. Go on R1 and check show IP interface brief. I have a proper IP addressing on the router number 1, and you can see the router configuration as well as so run section EIGRP. Come on. Oh, good. I have a proper EIGRP configuration on the router number 1 as well as on R2 as a show IP interface brief. So run section EIGRP now. And perfect, right? On R3 as well as show IP interface brief. So run section EIGRP. And awesome. And if you see by default, R3 is sending all this information to the R2. Can you see that? Show IP route EIGRP. I have all information. Even R2 is sending all information to the R1. But what I want, I don't want this person, right? I want to filter this guy. How do I filter? I just need to go on the router number 2 and say that, hey, access list 1, deny. Which route I'm going to deny? I'm not interested in this route, right? Filter it. And access list one permit any, and I'm going to call this guy into the distribute list, right? For the ACL number I'm going to use over there, ACL number one, and I'm going to call in the what direction, in what direction. I want to filter the route from the R2 and R1 as well as hit enter. What happened? This will apply the what I told you that if you're not going to match the interface, it will enable on all EIGRP enable interface. So how many EIGRP enable interface we have on the router number two? Two interface 0/0 and 0/1. Did I match the interface over there? No. If I'm not going to match, it will apply the distribute list on the this interface and this interface as well as route filtering changed. So guys, again, it's important, right? Again, it's totally depend on the scenario. I haven't matched the interface right now. If you don't match the interface, you can match it. For example, if you see the output right now on a R1, do I have this information right now? 1.0? No. I've filtered that one. I have filtered that one. Again, if you have a look the output difference, if I'm going to match the interface, let's remove this guy right now. Come on. And now if you come back to the R1, show IP route EIGRP, I do have maintained this information. Can you see that? Because I removed the EIGRP. 5 seconds ago, I learned this information. But if I'm going to call the interface number, take example, I say that, hey, I need to apply this ACL in one. Come on. 0/1. So it will only applicable on the 0/1 interface. You will have only one resync, right? Previously it was two resync was there, right? Router router had performed the two resync previously, but now single resync is happening on this particular interface because I applied the distributor list on this particular interface. So I just need to modify, or we can say that I just need to do the resync or the configuration change on this particular interface. Again, you will get the same output. So the thing is that how this thing is working, man. Simple. Task one, I want to filter 191 100, but I need to allow all remaining route. How do I do that? I just need to task with step number one, create ACL to match the route or whatever the name you can call it. Choose the route or call the interested route. Step number two, apply it. How do I apply it? You need to go in the distribute list and apply this guy. So for example, I have created the two ACL over there, do show run section access list. And need to apply. So I just need to go in the routing HRP mode, call this guy, and done. If you call the the interface, you can call the interface as well as again up to the scenario. If you have a look like this, for example, I want to receive the route on this particular interface, but I want to allow the route from this interface, and this interface, not this interface, filter the route from this interface. Then you need to match the interface over there. Again, it's totally situation, right? Whatever the situation that you're getting over there. It's good, right? So this is the how you are doing the route filtering. What route filtering is going to do, guys? It's just removing the unwanted information from your routing table. and it saves your memory and CPU as well, right? It saves some memory. If you just have a look over there, I'm going to remove this guy. Okay, this thing is spinning. And if you have a look, so IP root EIGRP, so IP root summary, was the memory is happening 640, right? 360. And I have all this information in my routing table, all 1, 2, 3, right? Let's do one thing on R2 and see the filtering. Now go on R1 and check. So IP root summary. Can you see that the amount of CPU and memory I'm reducing 360 to 640, 285, 112. It's good now. But you know, this route filtering that we did right through the ACL is not a scalable solution, right? Is not a scalable solution. If you have a look, if you have a look this topology line, forget this guy. Let's remove this person. If you have a look this scenario, right? How many routes we have? We have this amount of routes slash 24 slash 25 slash 26 7 20 29 30. Default route complete class A from starting range to the end range, complete class B from starting range to end range, and complete class C from starting to end. Not it's not an end, it should be 23 because I made it the 22. Tell me if I'm going to do the ACL and I want to filter the this is the discontinuous network, right? 25, 26, 27. I want to filter this amount of route. How many ACL it will require? Multiple ACL, multiple statements, right? I want to filter this particular complete subnet, multiple statement. So ACL, you know, the ACL is not like we are not using the ACL in the market. We are using, but ACL is not giving the good solution. ACL is not so scalable. To do the filtering, sometimes in or we can say some situation, it create more statement, and that again hit to the CPU and the memory utilization as well as. And the ACL is requiring little bit more process. It's require more process. So that's why they came with the mechanism is known as a IP prefix list. Same same work used to match the route, all the interested traffic. Same thing, nothing is different. They also have a like IP means what he's talking about the IPv4, right? Prefix means what he's talking about the route. List means what we have a multiple statement 1.0.0.0.0, 2.0.0.0, 3.0.0.0, and 4.0.0. multiple statements, and each statement has some sequence number. For example, sequence number 10. By default, it will go through the 5. Sorry, by default, it will go to 5, 10, 15, and 20. Like in the ACL, what is the default sequence number is happening? 10, right? 10, 20, 30, 40. In this one, we have 5, 10, 15, 20. This is called as a list. So IPv is what it's doing for the IPv4. You can do for the IPv6 as well. As it's not like that. You can do the, or what prefix means what a route, list means what or multiple statements we have. Same work they used to call the interested route. Choose the route. I'm interested in this particular person, right? On a single router, right? On a single router, you can have a multiple prefix list. And to identify those prefix lists, we need to give some identifier. And that identifier is known as what? Prefix list name. This name could be anything. Define the name CCI. If you want to define the number, you can define the number. You can define the CCI 123. Define the CCI 123. If you want to define some miscellaneous character, you can define the miscellaneous character. Up to you. Any name you can define it. Just to identify the prefix list. Can define the name. All good. So for example, I see that IP prefix list, right? Come on. IP prefix list, right? IP means what? IPv4 prefix list. I need to define the prefix list over there and define the name CCI. And after that, what happened? You need to define the action. Action will be what? Action could be anything. Either your action will be like same ACL, commit. Commit means what? I'm interested. Deny means what? Not interested. So I need to define the, like, I need to allow, right? Which route? I need to call the permit. I'm interested, right? And then after that, what? 192.168.1.0 slash what? 24. Now the good thing about the prefix, what I told you that as compared to the ACL, prefix list is very easy. In ACL, how do you match the route? Based on the wildcard mask. And that's, you know, the very tricky things for the freshers network engineer, right? Instead of matching the, like, you know, the route based on the wildcard mask, what prefix list allow you to match the route based on the subnet mask information, and you need to represent, or you need to call the subnet mask information in the concise way. Concise way in the sense of what? You need to define in the summary way in the sense of what? CIDR value. All good. So I just need to tell her, okay, what route I have, 191.60.100/24, and what is the submit mask of this guy. So I'm going to match the bits, right? At the same time, I'm going to match the what submit mask as well as. If both things will be matched, I'm going to take action. If both things will be matched, I need to take the action. That's it. So if you have a look on R1, if you see show IP interface brief, I do have all the interfaces that you can see in the diagram right now, right? All the interfaces we have. 12.1 that is starting, and then we have a loopbacks over there. And all the loopbacks is configured with the appropriate subnet mask that you can see right now. Okay, we have a default rod as well as that's configured static rod, and I redistribute that default rod into the EIGRP. So if you see show run section in EIGRP right now, I'm advertising all the route. I put the 0.0 network statement over there, right? No need to have this statement. Let's me remove this guy. No need to need because I already configured the 0.0. And I perform the reducer static. So now R2, I will have show all information in my routing table. Show IP, root, EIGRP, even the default route and everything. Perfect, right? Default route as well as. What I want right now, I want to filter this guy. I only need to allow this person in my R2 routing. So right now, R1 is sending all information to the R2. Right now, R1 is sending all information to the R2. My task is what? Task number 2. I want to allow what I want to R2 only mode. What I was to 1.0/24. I need to create the prefix list. If you see on R2, I say the IP prefix list. Define the name, right? As the Cisco will be their name, and this name is case sensitive, guys. It's not like that you can take any name over there. Not like you can, if you define the Cisco over there, you need to call the Cisco in the distributor list. Everything, every single character is like, case sensitive. And I need to take the action. Which action I need to allow this guy? And what are the statement we have in the routing table? If you have a look, the 1.0/1, just copy it from there. That's it. Same ditto. That's it. Hit enter. And I need to apply this guy distribute list one, not one. I call this guy the prefix list, right? And in the what's the name of the prefix Cisco? And we need to call in the inbound direction. If you not define the direction, define the direction only, in or out. And now have a look. Wait for some time. So do show history, and we are good to go. Applied. So now, if you see do show IP route EIGRP, what happened? I just have a single information. Did I deny? Did I deny anything in this statement? If you see, I'm only allowing. It means that like ACL, prefix list also does implicit deny, right? So if you see, I just have a single statement. I just need to create the prefix list over there, and very simple commands. Instead of matching the wildcard mask, I just need to call the submit mask information. If you do the wildcard mask, how will you do that? You need to call the 0.0.0.0 right? Like this. But how I did over there 255.255.250.0 like this, not like this. Again, guys, it's important. If you're planning for the CCI exams, I'm telling you, not even the planning for the CCI exam, who are enrolled for the CCI inter. So now take example, what is the next task we have over there? Let's remove the prefix list. I just need to go no IPA prefix list. If you say Cisco, I just put the name over there. That's it, nothing else. Cool. Next thing is what? Next task is or task number 3 are to only allow default route. Not default route. I can say that. One minute. R2 will not allow, but it allow. Now task is clear. R2 will not allow this guy, so I don't want this information now, not this one, but again I want all the single information. How do I call it? I need to match the statement, and now I'm going to create the instead of the permit, I need to create the deny over there. Deny, I'm going to deny this guy 1.0/24, right? And then what? I need to allow the remaining person because implicit deny is happening, Cisco. Now, here you cannot use the any keyword. Here you cannot use the any keyword. Any keyword will not work in the prefix list. Like you are doing the any keyword in the ACL, right? What is the use of any keyword? Any route. Any route, that is the meaning of any keyword, right? Tell me, what is the use of this route? Default route. What is the meaning of default route? If any traffic is coming to me, doesn't matter what IPs are there. In the destination, doesn't matter what IPs there. According to my routing table, I need to forward the packet to the 2LR2, right? It's matching everything, right? So what we have to do over there, I need to call the prefix list. Let's go permit or 0 or 0 or 0 or 0 or 0/0. Now, if I'm going to hit enter over there, try to understand what happened. See the behavior. If you understand this part, your complete prefix list will be clear. What happening? Do show IP root EIGRP. Can you see that? What happened? I deny this prefix, right? I deny this prefix list. Okay, that was my task to deny this particular person 1.0/24, but I need to allow all of them, right? All of them from here to here. But what happened? It's only allowing the default route. The reason, do you know what happened? Because the statement that I put over there, right, 0.0/0, it's only matching according to your routing table to this guy. It's only matching. I need to match every single person, 25 submit mask, 26 submit mask, 27, 28, 29, 30. Even if you have a 31, 32, I need to match all the submit masks, all single submit mask I need to match, right? So if you need to allow everything, every single thing, then what we have to tell this guy, hey, listen, you need to match You need to look up the submit mask information. Any doubt, doesn't matter. Any doubt, doesn't matter. We need to look up the submit mask information slash 32 as well as less than slash 32. IPv4 size 32, right? 32 bit. The size of IPv4 is what? 32 bit, right? I didn't tell this person, hey, you need to match every single route. Doesn't matter what submit mask they have. It can be 0 or 0. It can be /8. It can be /25, /26, /27, 28, 29, 30, 31, 32. Every single thing less than or equal to. Less than or equal to. So you have a less than, equal to, and you have a greater than, equal to. I need to match the complete /32, right? Any route that has a submit mask, any submit mask, I need to match every single thing. And now if you see do show IP route EIGRP, I do have all information, even the default route as well as. That was my task, right? Not this one. So I don't have 1.0/24, but I can have all the route. All good? Yes. Now, so what was the statement? We have to show history. Now you can see the statement was like this. So already the I already applied this distributed in the in the EIGRP in the EIGRP, so I don't need to apply it again, right? So let's remove this guy, and this is my statement. Task number 4. R2 will only R2 will not allow /25 till /27. It means that now I want to filter this guy, this guy, this guy. See the flexibility. Middle of them, in between. How do I create it? I just need to create the prefix list now. IP prefix list, Cisco, right? And I say that I need to deny this guy, right? I'm just going to match the 2 octets. Can you see that? Because the third octet is changing happening right now. The first octet is matching, matching, matching. Second octet is also matching, 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 matching. The third octet variation is happening, right? So I'm not going to call the third octet. Third octet will be 0, 0. I'm just going to match the 2 octet, right? I'm just going to match the 2 octet. And after a word, I'm telling this person, hey, you just need to look the 16-bit that have matched 192.168, whatever the route that is coming with the 192.168. You just need to look the 16-bit. But if you see, I have a lots of 16-bit is happening. This is going to match this guy, this guy, this guy, this guy, this guy, this guy, this guy. Everything will be filtered. But I'm telling this guy, hey, wait a minute. Once you have done with the 16-bit, now look the submit mask that has a greater than equal to 25 and less than equal to 27. See the flexibility now. I'm telling this person, hey, you have to see the 16-bit, but at the same time, you need to look up the submit mask information as well as those has a 25 and less than 27. So only the 25, this guy, 25 to this guy will be filtered. So now I need to allow the rest of the guy. All done. It's not like that you can clear the 32 always. Like according to my scenario, I have a slash 32. I can make a slash 30 as well. Copy. All great. I don't have a one, two, three, four. Can you see that 2, 3, 4 is there? Yep. Do you have a 2.0, 2.0, 3.0, and 4.0? No. So it's not like always we need to create the 32 always, right? So you can see I just matched with the 30 as well as because I have 31. So 30 is allowed. And any to 25, 26, 27 is not. Same thing, for example, now take example. I want to pass number 5, and we can call this guy. Hey, R2 will not allow any route that has a submit mask lower than slash 20, but make sure they belongs to this submit range. So what we have are the prefixes over there now. So same thing, slash 16. I just need to call this guy as a less than equal to 29. That's it, right? Call this guy and have no IP prefix list. If you see do show IP prefix list, what is the by default sequence number is taking? Did I put the sequence number there? No. By default it will take the 510. If I want to define the sequence number, take example no IP prefix list Cisco, and either the IP prefix list Cisco, and either permit sequence number. Sorry, first need to define the sequence number. Two or their permit, and right now I set the 16 bit, and you have to do the less than equal to 29, right? And I said IP prefix list Cisco permit. So I'm not defining any sequence number in the last statement, right? So I define the two over there. So what happened? It will go through the two, then add the 5. So 2 plus 5 7 plus 5 12 plus 5 17 and plus 5 22. So always the increment will happen 5. Doesn't matter what sequence number you put in the first. If you don't put the any sequence number, by default you will take the 5 10 15 20 25 20 30. So if you see the do show IP prefix list 27, and now R2. Do I have any information? Oh, my bad. It has to be denied, right? All good. So wait for some time, do so if you do EIGRP and see the magic. I don't have any doubt. 29 not there, 28 not there, 27 is not there, 26 is not there, not even the 25, not even the 24. I do have a 30. But take example, if R1 is going to create the summary dot, interface 0/0, IP summary address EIGRP. I'm going to do the summarization for this particular route, right? 1.0, 2.0, 3.0, right? How do I call it? Will I going to allow the summary dot over there? Not, because it's coming in the /22, right? And /22 also will not allow. Do show IP EIGRP. Not there. Problem, right? Because he's sending a /22, right? 192.168.0.0/22. And in my prefix list statement, what we have matching over there, deny everything that is a slash less than 29. So if you want like same thing, task number 6 now. But if you want, what happened? I said, hey, lower than 70 plus 29, but not 24. Because according to my diagram, we have 25, 25, 26, right? I want to filter from here, downside, but till this point only, not the 22. So what we have to call over there? I need to match the less than 29, greater than 24, and less than 29. So now it will allow the summary dot. Because now I say the greater than 24, because my summary dot is what? It's just 22, right? So it will allow the 22. Again, guys, I'm telling you, you need to do the practice of the prefix list, right? It's not hard. Do you know what happened? You didn't practice this thing, that's why it's look like hard. But it's very, very easy. You just need to call the AC prefix list and see, I do have a summary. Same thing if you're gonna filter that out like this. Task number 7. Greater than and equal to. Here also equal to. I want to filter like this. So I just need to say, hey, do one thing. R2 will not allow any data that has a summary was greater than equal to /9. Let's do one. Just put a greater than 29. That's it. So it will filter the 29 and 30. So now do show IP do to EIGRP. I don't have a 29 and 30. I have a 28, right? 20 is there, 80 is there, but 29 is not there. So this, can you see that? That's the, like if you only allow, take example, I want to allow task number 8, only allow default route. Then simply default, match the default. And I need to call this guy. That's it. So now, so Nike is on. Do swipe your EIGRP. For example, you need to allow task number 9. Allow all the route, not all the route, deny all the route. All means all, every single thing, even the default route as well as. So how do I get it? So Mike is on. If you have a question, you can ask me. Otherwise, mute your mic. Now, see the behavior. Now, do I have anything? Nothing is there. Nothing. Every single thing, even the summary dot default or class A, class B, class C, class plus, every single thing. For example, now I want to filter the complete class A. Complete class A. How do I filter? Complete class A. So for the complete class A, what we have to do over there? What is the range of the class A? 100.0.0.0.0.0 to the 126, right? What is the binding of 1? 0, 0, 0, 3, 4, 5, 6, 7, 8, 3, 5. What is binding of 186? 0, 1, something like this. 1, 1, 1. How many bits are matching over there? 1 bit. What is the range of class B? 128, 29, right? 29 or 28? 29. 28 is there, no? I think so. 28 is there.
128, 120.
Right? And 191. The range, right? What is the binding of this guy? 128. 1, 0, 0, 0, 3, 4, 5, 6, 7, 8. What is the binding of 191? 1, 0, then 1, 1, 1, 1, 1. Something like this. How many bits are matching? 2 bit. What is the binding of class C? Starting range, ending range, 23.
23.
Binding 1, 1, 1, 0, 0, 0, 0, 0, 3, 4, 5, 6, 7, 8, 23, 1, 1, then 23, 0, then 1, 0 something, 1, 1. How many bits are matching only? 3 bits. So for the class A, 1 bit I'm matching, right? So I need to only allow, or we can say only filter the class A. How to do that? I said IP prefix list, deny, just go, deny, 0, 0, okay, was a range, 1 bit, somebody was getting 8, less than 8, starting with 0, right? It's 1. I think it's starting from 0. You can also call match the 0 over there. For the class B, for example, I want to deny the class B. I don't know class C right now. I will deny class B, Cisco. Deny 128. That's a starting range. Slash how many bits I'm matching to match? 2 bits, right? Less than, greater than, equal to 17 was default is 16, and less than 16 over there. So it filter all the class B, every single IP address.
What if I have class B address with class C subnet mask?
Only class 2 they will match it over there. Then you have to create the next prefix list over there.
Okay, I need to have another prefix list again, right?
Yep,
I need.
yep. It only match the class pool because I match the class pool only. See that?
Oh, okay, fine.
Yeah, there's no class B now.
Okay, okay. That
So for
126
example, yeah,
here, right?
sorry. Go come back again.
That 126.0.0 is a class, is in class. Okay,
8 is this.
fine.
Same thing you now match the class C now. So I need to call the starting range format deny 192.0.0.0.0. 3 bits I'm going to match. Greater than slash 24, less than slash 24. Okay. What happened? Strike, right? Oh, sorry. And allow the remaining. So now it will match everyone. Do show IP root agent. I don't have a class C now. So complete class C has filter. So you know the every all the possible scenario, right? Class A, so you have all the possible scenario in front of you guys. Every single scenario I have seen. This is called as a route filtering. Interested out, allow it. Not interested, deny it. Whatever the interested route you have, you can allow it. And whatever the interested route you have. So in this case, we have also seen the summary route concept. So there's a summary route over there. So we have seen all the default concept, summary route concept, every class pool, class A, complete class B, class C, every single one. This is how your prefix list is going to be work, guys. So prefix list or ACL, if I'm going to conclude this part, both are have a same meaning, right? Matching the route. But prefix list is more powerful, right, as compared to the ACL. All good. Any questions? Perfect, guys. So I'm done for the route filtering now. So tomorrow we'll do the route manipulations and then we'll done.
Okay, sir.
Sorry.
I said okay.
So route manipulation and build done. So guys, I think so I have shared the OSPF drive link to you guys, right? Please go through the CCNS stuffs, right? Please go through the CCNS of the OSPF driving, like what is DR, BDR, whatever the states we have. I have shared the drive link in the group. So please go through that. Okay, because I'm telling you, like, this thing I'm not going to cover the D or the DR and BDR. These are the very basic CCNA part. Because if I'm going to take this class DR and BDR, it will take for me the complete 1 week. A complete 1 week it will take, right? So already videos are there. Just watch it, right? Because these are the proper CCNA part, and you must need to know about this because already we have went through that the complete CCNA behavior, like a feasible successor neighbor table, like the topology table of the EIGRP. So I'm suggest you please watch the DR and BDR CCNA stuff. I have already said that OSPF dialing. You just need to watch the first 4 videos. That's it.
ऐसा OSP कब स्टार्ट करो यार?
Yeah.
OSP कब स्टार्ट करनी है?
Maybe Wednesday or Thursday, maybe.
Oh, okay. सर हो जाएगा.
All good? Any questions, anyone?
Yeah. No.
Fine.
Yeah. Yeah.
मैनिपुलेशन ये प्रीफिक्स लिस्ट ही हुआ ना, मतलब
क्या चाहिए?
राउट मैनिपुलेशन.
This is called route filtering, buddy. This is not called route manipulation.
ओके, राउट फिल्टरिंग.
हाँ.
मुझे लगा आपने वो कंप्लीट कर दिया राउट मैनिपुलेशन.
नहीं. Yeah. Anyone? No. All good, guys. So have a great day. Yes, tell me.
Notepad also. Try to upload the notepad.
You want a notepad?
Yeah, tasks. Yes,
Okay,
tasks.
I'll upload it.
Based on that, I will make apps.
Yeah, I'll upload it. I'll send in the WhatsApp link.
Yeah, can.
Okay, guys. See you tomorrow. Bye bye.
ठीक है.
Thank you. Bye.
Thanks.